Welcome back. In the last session, we just analyzed and we got to know V naught of t is equal to minus 150 into Va of t. I hope this is clear, right? Therefore, tell me what is the answer. Right? Everyone understood the procedure, right? This is what the circuit, which is RC coupled CE amplifier. This is nothing but RC coupled CE amplifier. Theoretically, we already studied. And a problem is related to AC analysis. Then we got AC circuit. Then V naught of t, Va of t. Then we got this. Okay. And maybe just to explain, and what are the options? Option A, V naught of t, it is already there, but I'm just explaining here. Minus 150, 1500, minus 1500 into A cos 20t plus B sin 10 to the power of 60. Option B, V naught of t is equal to minus 150 into A cos 20t plus B sin 10 to the power of 60. Option C, V naught of t is equal to minus 1500 into B sin 10 to the power of 60. Option D, V naught of t is equal to minus 150 into B sin 10 to the power of 60. Therefore, what is the answer? What is V naught of t? Minus 150 into Va of t. What is Va of t? A cos 20t plus B sin 10 to the power of 60. Right? Therefore, what is the answer? Answer is V naught of t is equal to minus 1500 into A cos 20t plus B sin 10 to the power of 60. Is this clear? Right? Therefore, whatever procedure we applied, we got the answer and then we used and then we got it, right? Therefore, this is convincing you, right? But let me tell you, this is not the answer. For example, I just told before 10 seconds, I told option A, then you felt happy and then let us say you closed the video. Then what will you think? Option A. But if you continue further video, just now I told that it is not correct. Then you have to rethink. Why? Remember, if you see, yes, sorry, my fault. Option A, sorry, option B, but option B is not correct. Because minus 150 into A cos 20t plus B sin 10 to the power of 60, right? Therefore, we thought option A, but sorry, option B, but option B is not correct. Why? That's what. Remember, we got the frequency response of RC coupled CE amplifier. What is that? The frequency response of RC coupled CE amplifier is, this is what is the frequency response, right? Now, this is what is our mid-band gain. This is what is our mid-band gain. Whatever gain we got now, I told you, right? Whatever gain we calculated using H parameter model, right? That is what is assuming all capacitors are short circuited. When all capacitors are short circuited, then only we got AC circuit, right? Means all capacitors are short circuited from this lower cutoff frequency only. Therefore, this is what is mid-band voltage gain which we calculated. Therefore, this is what is our mod AB, let us say, right? Therefore, now if that is what is the scenario, it cannot amplify low frequency signals, right? And it cannot amplify very high frequency signals. Now, let's see, whatever Va of t, which is A cos 20t plus B sin 10 to the power of 60, this is nothing but omega, cos omega t, let us say this is omega 1, and this is sin omega t, let us say this is sin omega 2. Let's see what is the frequency component. Therefore, tell me what is omega 1? Omega 1 is nothing but 20. What is omega 2 pi f? 2 pi f1 is equal to 20. then F1 is equal to 20 by 2, 10. 10 by pi, pi is 3 point, then approximately 3 hertz. What is 3 hertz? Very low frequency. I can say almost nearer to 0. When I say almost nearer to 0, what is the gain of the amplifier? Gain of the amplifier is 0, means indirectly A cos 20t is low frequency component of your input signal. The low frequency component of your input signal will not be amplified because of the coupling capacitor, right? Therefore, it will not amplify A cos 20t component of your input signal. Let's see what is the second one, sin 10 to the power of 60, right? Therefore, what is omega 2? 10 to the power of 6. Then 2 pi f2 is equal to 10 to the power of 6. Then f2 is equal to 10 to the power of 6 divided by 2 pi. What is 10 to the power of 6? 1000 kilo, right? 1000 k. 1000 by 2, 500 k. 500 by 3 something. Therefore, approximately you can say around 160 kilohertz. Just approximately 160 kilohertz. 160 kilohertz is like kind of what, less than mega ohm, kind of mid-band gain or mid-band frequency. That is what people treat. Then tell me, this is what is mid-band frequency, where your amplifier will amplify with the gain of minus 150 whatever we got. Therefore, only the second component of our input signal will be amplified with the gain minus 150, because whatever AC circuit we considered, right? That is what is, there is no capacitors assumed shorted, but they are shorted but for a given frequency. Then this is what is your AC circuit, and we got gain of minus 150. Therefore, what is the answer? Answer is D. It amplifies only the second frequency component with gain minus 150. Hope this is clear. Okay, take this. Therefore, you can say 3 hertz whatever we got. You can say this is what is 3 hertz. Omega 1 is equal to 3 hertz. Maybe omega 2, this is what is omega 2, sorry, F1. Then F2, let us say F2 is equal to 160 kilohertz. Here, whatever gain we got, 150, that is what is applied. Okay, fine. This is interesting problem. Over? Okay. Now, problem number 8. Okay. What is problem number 8? Remember, this is linked answer problem. What is linked answer problem? For the second bit, first bit answer is required. Means, if you solve the first bit which is correct, then only second bit will be correct. If first bit is wrong, because the first bit answer is the input to the second bit, that surely second bit also will be wrong. Okay? Remember, if first bit is wrong, no need to evaluate second bit. Why? Obviously, second bit also will be wrong. Why? Because first bit is wrong. Let us say first bit is wrong, second bit is correct. How can you get second bit correct if first bit is wrong? Then it is, you didn't solve, you got it something like that. That is called luck. Therefore, that is the reason why if first bit is wrong, second bit will not be evaluated in the examination. That is making sense, right? Yes. Take this problem. The problem is, in the following transistor circuit, VBE is equal to 0.7 volt. VBE, what is the problem number? Problem number 8. VBE is equal to 0.7 and RE is equal to 25 millivolt divided by IE. Something is given. Let's see. RE is equal to 25 millivolt divided by IE, and beta and all capacitances are very large. Beta and all capacitances are very large. I'm just representing like very large. Means tends to infinity, but absolutely they are not infinity. Very large means you can neglect base current with respect to collector current, and IE is equal to IC. That is the meaning of beta very large. And what is the meaning of C very large? C very large means what? For low frequency itself, means for the signal frequencies whatever you are giving at the input, the capacitors, external coupling capacitors, whatever you have can be assumed as short circuit. That is the meaning of it. Means for AC analysis, you assume the capacitors as short circuit. That is the meaning of it. Okay. This is what is given. Now, circuit is also given. What is the circuit? That is nothing but again RC coupled C amplifier. Then asking for what is the first bit? The value of DC current IE. Therefore, the first bit is the value of DC current capital IE. What is capital IE? Then second one, the mid-band voltage gain. Mid-band voltage gain. Mid-band voltage gain. That is what is second bit. Therefore, first bit, what are the options? Options are 1, 2, 5, 10. 1 milliampere, 2 milliampere, 5 milliampere, 10 milliampere. Similarly, option A, mid-band voltage gain, minus 180, minus 120, minus 180, minus 120, minus 90, minus 60. Okay, and the circuit is, this is nothing but RC coupled C amplifier only. $2.3K, 3K. Now load is given. This is what is the load, which is 3K. Okay, and power supply. Yeah, power supply is 9 volt. Therefore, this is what is given. Right? This is what is given, and this is nothing but your IE, the DC current. Okay, that is represented. Therefore, try to think. Actually, this is for 4 marks. GATE 2008. Okay, first bit is for 2 marks, second bit is for 2 marks. Therefore, total 4 marks. One problem for 4 marks. Significant. Remember, Okay, that's fine. Now, tell me, according to our procedure, circuit is given. Now, is problem related to AC analysis or DC analysis? Actually both. Because if you see the first bit, asking for DC current, then DC analysis problem, then we need to take only DC circuit, don't bother about AC inputs and capacitors. Then second bit is related to mid-band voltage gain, means AC analysis. Then don't bother about DC signals. Okay? Let's see, to solve the first bit, right? Therefore, to solve the first bit, problem is related to DC analysis. If the problem is related to DC analysis, then immediately we need to consider DC circuit. Then input KVL, output KVL, or whatever maybe you can use. Therefore, what is DC circuit? This capacitor is open. This capacitor is open. This capacitor is open. It is simply left with what? Self-bias circuit. Therefore, it is left with self-bias circuit. This is what we had seen. This is 2.3K, 3K, 20 kilo ohm, 10 kilo ohm, and this is 9 volt. Okay, this is what is the circuit. Now, what do you want? We want to calculate what? IE, the current which is what is flowing through 2.3K. That is nothing but your IE, right? We got to know DC circuit, but you remember I told you, right? R1, R2. The moment you have, if you want to solve self-bias circuit, just apply Thevenin's theorem. Then you will get VThevenin, RThevenin. Then apply input loop KVL. Then you can find IE. That is straightforward. Therefore, tell me, applying Thevenin's theorem. Then apply Thevenin's theorem. What do you get? This is 2.3K, 3K and 9 volt. Now this is RThevenin and VThevenin. And one more point I want to tell, no need to calculate RThevenin. Why? Because you can neglect the base current. Why? Beta is infinity or very high, sorry. Beta is very high. When I say beta is very high, you can neglect IB with respect to the current IE. This is what is your IE. Therefore, if you neglect IB, the drop across RB can be neglected, which is what is 0. Then simply this VThevenin is equal to this voltage plus this voltage. Okay. What is VThevenin? Therefore, VThevenin is equal to what? 10K, voltage divider network. 10K divided by 20K plus 10K into 9. That is what is VThevenin. Therefore, 10K divided by 30K into 9. This is nothing but 3 volt. No need to calculate RThevenin. But if you want, you can calculate, that is done. Therefore, VThevenin is equal to 3. Therefore, input KVL. When you apply input KVL, what you get? VThevenin is equal to, right? We can neglect it later, but I am writing here. IB into RThevenin, IB into RThevenin. The drop across is plus VBE, plus VBE, plus the drop across 2.3K, IE into 2.3K. This can be neglected 0 because since beta is very large. Because beta is very large, you can neglect IB with respect to IE. Okay. Therefore, now what is VThevenin? We already calculated. 3 is equal to what is VBE? 0.7 in plus IE into 2.3K. Then tell me what is IE? IE is equal to 3 minus 0.7, 2.3 divided by 2.3K, which is 1 milliampere. Therefore, what is your IE? We got first bit answer. What is IE? IE is equal to 1 milliampere. Therefore, answer is A. Because problem is related, first bit is related to DC analysis. We need to find DC bias current through emitter, from emitter through 2.3K. Then we took DC circuit, which became self-bias circuit, applied Thevenin's theorem to find VThevenin and RThevenin. Then VThevenin, no need to calculate RThevenin. Anyway, we are going to neglect IB. Therefore, whatever irrespective of RThevenin, this part will be 0. Then it is left with very simple IE. Then IE we calculated, we got 1 milliampere. hope everybody understood the procedure. Procedure is very important. Okay. And second bit is related to AC analysis. Then second bit is AC analysis. Then we need to consider AC circuit. If you consider AC circuit, you will get common emitter amplifier. Then we need to calculate the formula. We need to apply the formula and calculate the voltage gain. Okay. Done. Done? Okay, now let's see AC analysis. Okay. Second bit. Second bit. The problem is related to AC analysis. Okay. AC analysis. Then immediately we need to consider AC circuit. Therefore, what is AC circuit? This is the transistor. Here this is connected to ground because C is very high. When I say C is very high, for signal frequencies at the input, this is short circuit. Therefore, emitter is connected to ground. Now this is short circuit. 9 volt is connected to ground for AC analysis. Then 3K is coming in parallel to 3K. Then your RL dash effective load is nothing but 3K in parallel to 3K. This is your V0. And at the input side, this 20K is coming in parallel to 10K. That is in, and this is short circuit for AC. Therefore, this is what is coming in parallel to the input signal. Voltage source in parallel to resistor, voltage source. You can ignore that part. Therefore, this is what is our VI. Right? collector, emitter, base. Therefore, what is this? This is nothing but your CE amplifier. Actually, no need to draw again and again, but I'm just drawing for your understanding purpose. If you do multiple times, we can visualize. And we know this is RC coupled CE amplifier. Under AC analysis, you'll get common emitter configuration only. That is what we need. That is what we developed. Therefore, now this is what, right? Therefore, now tell me. Therefore, what is 3K in parallel to 3K? 1.5 kilo ohm. Common emitter amplifier. Can I go for simplified model? Obviously. What is the load value? Effective load value? Less than or equal to 4K. Therefore, we can go for simplified model. Then what is voltage gain? Mid-band voltage gain. Whatever we got, that is mid-band voltage gain, right? AV is equal to minus HFE into RL divided by HIE. This is what is the voltage gain. Tell me what is HFE? Beta, very high value. What is HIE? We don't know. Don't read that HIE is not RE. We don't know what is RE, right? I didn't tell what is RE. What is HFE by HIE? We don't know HFE, right? We don't know HIE. Then how will you calculate voltage gain? H parameters are not given. Therefore, we cannot solve the problem. Therefore, you will get extra free marks because we cannot solve the problem. Problem is incomplete, right? Right? Yes, we need H parameters to solve the problem. Maybe in previous problems, HFE is given in terms of beta and HIE is given. We substituted, we got it. But here H parameters are not given. But if you observe clearly, what is the problem? Problem is linked answer problem. What does it mean? For the second bit, first bit answer is input. What is first bit answer? What is first bit? Current. How current is input to solve this? That's why I told you one thing, right? This is nothing but what is HFE by HIE? HFE divided by HIE. Can I write it as, which is nothing but GM, right? If you consider hybrid pi model. Therefore, minus GM into effective load, what you have? Let us say RL dash. Therefore, now it is RL dash. Because what is effective load to your transistor, that is what your load. Okay? Therefore, now, what is our GM now? We know that, you write this as equation 1. We know that, what is GM? GM is equal to IC by VT. What is IC? Because beta is very high, then IC is nothing but IE. IE we already know. Therefore, what is IC? IC is nothing but IE. IE divided by VT. What is IE? That is known to you. But what is VT? 26 millivolt at room temperature. But temperature is not specified in the problem. Then what VT will take? 0 temperature? 120 degrees Celsius temperature? We don't know, right? We have to take typical temperature, right? If nothing is given, yes, we have to take typical temperature, which is 27 degrees Celsius. Then we can solve the problem. But remember, something is given. That is nothing but a small RE. I'll explain. The small RE is nothing but the impedance seen into emitter. The impedance seen into emitter. What is impedance seen into emitter? Actually, that's okay, but okay, that part I will derive. I'll try to derive from MOSFET. The impedance seen into emitter or the impedance seen into source is nothing but 1 by GM. Okay, that part I will explain, but I will try to correlate when I explain MOSFET. If I explain now, you will not understand the reason and the logic behind it. Okay, now this is nothing but VT. Therefore, this is nothing but 1 by GM. Therefore, 1 by GM is nothing but VT by IE. VT by IE. Therefore, what is VT? 25 millivolt. Indirectly asking you to take VT 25 millivolt. Therefore, what is IE? IE is equal to, which we already got, 1 milliampere, and VT is 25 millivolt. Let us say you didn't understand about this. If you don't understand this, what will you do? IE 1 milliampere, VT will take 26 millivolt only. Then you will not get any issue. You will solve, you will get the answer. That is what is called luck. Right? Okay, even though you don't understand. But remember, this is nothing but 1 by GM. Okay, small RE is nothing but 1 by GM. Small RE is nothing but impedance or resistance seen into emitter. which is nothing but your CC amplifier output impedance, which we got, right? What is CC amplifier output impedance? What is CC amplifier output impedance? R naught for CC amplifier. What is the impedance seen into emitter? Impedance seen into emitter is nothing but output impedance of CC amplifier. We know that R naught is equal to Rs plus HIE divided by 1 plus HFE. Let us say here in this case, what is source value? Directly this is what is your VI, right? This is what is your VI, and that there is no practical voltage source. Let us say Rs is 0. Or let us say even though you have practical voltage source, you are going to insert CC amplifier, then the CC amplifier output impedance is nothing but 0, that you can neglect. Then this is nothing but what? HIE divided by, can I write 1 plus HFE approximately HFE? Then what is HIE divided by HFE? We know HFE divided by HIE is nothing but GM. Then HIE divided by HFE will be equal to 1 by GM. That is what it is. Okay. What is output impedance of CC amplifier? CC amplifier is nothing but what? The impedance seen into emitter. That is nothing but your CC amplifier. That is what your small RE impedance seen into emitter, which is CC amplifier output impedance. CC amplifier output impedance. Okay, that is fine. Now, what is this value? Which is milli will be cancelled 1 by 25 ampere per volt. This is what is your GM. Now substitute that in equation 1. 1 implies what is your voltage gain? AV is equal to minus 1 by 25 into load is nothing but 1500 ohm. Then what is this? 25, 40 is 1000, 20, therefore 60, minus 60. Therefore what is your voltage gain? Minus 60. Your RS is 0. The source is not there here. If you take, I already derived all these things, right? H parameters to GM, and what is GM? From hybrid phi model to H parameter model correlation. Over. Now, next problem, problem number 9. With that I can say, I can stop the session. Then we will continue in the next session. Problem number 9. The amplifier circuit shown below uses a silicon transistor. Silicon transistor means VBE 0.7 and all those things. Okay. The capacitors CEC and CE can be assumed to be short at signal frequency. Yes. Typically for signal frequencies they are short. To be short at signal frequency, and the effect of output resistance R0 can be ignored. What is the meaning of it? The effect of output impedance R0 can be ignored means neglect base width modulation. It is like neglecting 1 by HOE. Okay. And we have to neglect immediately HRE. But output impedance R0 we represent from hybrid pi model. Whatever it may be, this is effective output impedance that can be neglected. If CE is disconnected from the circuit, CE means capacitor CE is disconnected from the circuit, which one of the following statements is true? First of all, what is the circuit? This is nothing but the circuit is, this is problem number 9. Circuit is, you need not draw because it is already there in the workbook. Just to explain, I am drawing it again. This is what is CE. Okay. And this is what? 2.7K, 0.3K. 2.7K and 0.3K and 800K VS. Right, these are all coupling capacitors. Okay, power supply is given. Yes, that is what is 9 volt. This is what is given and asking for what? This is what is our input impedance. Asking, this is input impedance, and this is what is our, where you are going to connect load here actually. Actual load is this, and this is what is our R0. Okay, this is what is given. I didn't draw anything extra. This is what is given in the circuit. Okay, Ri and then R0. Ri and R0. Okay, then yeah, if this is what is given, which is true. Now, if C is disconnected, then input impedance increases, magnitude of voltage gain decreases. He is speaking about Ri and AV. Okay, when I say this, he is speaking about Ri and AV, right? Now, first of all, before disconnecting CE, therefore tell me Ri, input impedance, voltage gain, all are AC parameters or DC parameters? AC parameters. Therefore, we need AC circuit. What is AC circuit? Right? AC circuit is nothing but, I will not draw now. Let's try to understand intuitively. AC circuit is nothing but what? Short circuit. Short circuit. CE is there. Let us say CE is there. The capacitor CE is present, not disconnected. Right? Then short circuit. Short circuit. Basically, this is nothing but what? This is nothing but your common emitter amplifier. Then if I say common emitter amplifier, and this is what is given as VI. Okay. This is nothing but common emitter amplifier. Then what is input impedance? And what is our load? Load is not connected here, but for the timing for the amplifier, if load is not connected, 2.7K, we can go for simplified model. What is Ri? Ri is equal to HIE. But that is what is the Ri. Very important point. Ri, that is with respect to transistor. Therefore, whatever we calculated, remember, from the input impedance definition, let us say this is what is your Ri1. This is what we calculated from your transistor amplifier. C into your transistor. But what is Ri? Actual Ri, your actual Ri from the circuit is nothing but whatever Ri you have from the transistor, that is Ri1 in parallel to, because for AC analysis this 9 volt will come to ground. Therefore, this 800K will come in parallel to the transistor input impedance which we calculated from AC analysis. Therefore, that 800K in parallel to this. Therefore, this is what is your input impedance. Okay, that is what is fine. Therefore, let us say this is what your Ri1. Therefore, what is Ri1? Ri1 is equal to HIE. That is fine. Then what is voltage gain? Because this is common emitter amplifier. What is voltage gain? Voltage gain is equal to minus HFE into RL divided by HIE. This is what is our voltage gain. If C is present, because this is what is short. When this is what is short, we got it. Now C is disconnected. If CE is disconnected, if capacitor CE is disconnected, then what is this amplifier? Here this is CE amplifier. Now this is, when CE is disconnected, then this resistor is there. Then this is nothing but CE with RE amplifier. CE with RE amplifier. Then what is your Ri1 which we calculated? I am speaking with respect to input impedance from the transistor. Okay. Therefore, what is Ri1? We calculated CE with RE amplifier input impedance. HIE plus 1 plus HFE into RE. Right. Then what is voltage gain? Your voltage gain we got ratio of resistors, actually minus HFE into RL divided by HIE plus 1 plus HFE into RE. This is what we got, right? Then we know that it is approximately minus RL divided by RE. This is what we got, right? Therefore, now we got to know. Therefore, tell me, if CE is disconnected, overall observation, what about your input impedance from your transistor, Ri1? I am not speaking about Ri, because if you know Ri1 in parallel to 800K is nothing but your Ri. Therefore, if Ri1, if you know, then we can comment on Ri, because we are not calculating what is absolute input impedance, we are calculating increases or decreases. That is what is your problem statement. Okay. Therefore, now tell me, what is Ri1? Your Ri1 is equal to, your Ri1 is increasing or decreasing? That is what is increases if you disconnect CE. What about your voltage gain? Your voltage gain, magnitude, right? Magnitude wise, this is decreasing. Okay, take it. Therefore, what is the answer? RI should increase, AV should decrease, magnitude of AV should decrease. Option A is the correct. Okay, take it. Remember, if Ri1 is increasing means definitely Ri also will increase, because Ri1 in parallel to 800K is nothing but your input impedance. Okay, I'm just highlighting, maybe in some problems we need it. They'll ask Ri, but whatever we calculated from AC parameters, right, from AC analysis, the transistor input impedance, the transistor output impedance, that is what we calculated, right? That is very important point. and transistor voltage gain, transistor current gain, everything we calculated with respect to transistor. But now Ri, in this case what is Ri? The input impedance with respect to the source. Then we have to take 800K in parallel to Ri1. That is what is our input impedance. Okay, that's fine. Let me have some water. I think this is what is enough for this session. Next session we will solve 10th problem. Okay. Answer is A. Your input impedance is increasing and your voltage gain is decreasing. If you disconnect CE, that we know, right? If CE is present, there is no negative feedback. If CE is not there, negative feedback. Therefore, your voltage gain will decrease, but stability will increase. That is stable, but this is not stable. We have seen all the concepts before. Okay. And one more thing, what is RL here? RL is nothing but 2.7K because nothing is connected here. That is 2.7K. If something is connected, effective load will be your RL. Okay. Thank you.